right, so let's look at tutorial sheet 8, P191, and question 1 reads, a block weighing 20 newtons is put up a rough incline of 40 degrees. A 12 Newton force of friction opposes the motion. The block is pulled at constant velocity by a force acting parallel to the incline. Draw a free body diagram and use it to find A, the applied force, B, the coefficient of kinetic friction, and C, the mass of the block. So this is a very simple question. We've been given to say we have a block weighing 20 newtons. So let me draw my free body diagram. We have a block, or first we can say we have an incline like that of 40 degrees. Then we have a block here weighing 20 newtons. So they've said this block is being pulled up an incline. And as it is being pulled, there is a force of friction. And we know to say since the force of friction, it is opposing the direction of acceleration or the direction of motion. So I'll say I have a force there, which is a force of 12 Newton opposing motion. Then we can also look at the natural forces that are going to exist if we're talking about an inclined plane, because we know the value of weight that we have, the magnitude of weight that we have is going to exist in two different axes. We have one in the vertical axis and one in the horizontal axis. So I'm going to resolve my forces. I'll say I have a force there, which is in now what is going to be established as the y-axis. This is also going to be equal to 40 degrees. And this will be mg also, or the weight itself. So since it is adjacent to the theta, which is the 40 here, we're going to say this is 20 cos 40. Then in the horizontal axis, we are going to have another component, which will be 20 sine 40. We're going to have 20 sine 40. Then there is the actual force that is producing the motion. Since this block is being pulled up the incline, there will be a force F. I'll just label it as a force F, which is pulling this incline up, or which is pulling this block up the incline, sorry. So these are the forces, or this is a free body diagram showing all the forces that have been described in our question. And part A of the question is saying we should calculate the applied force. We should calculate the applied force. So in order for us to calculate the applied force, we're going to look at the forces that are in the x-axis, on the horizontal axis. So which forces are those? We have the 20 sine 40, we have the 12 Newton, which is the force of friction here, and we have F itself, which is the force that is producing action. So they've told us to say the motion is at constant velocity. And if motion is at constant velocity, that means acceleration is equal to 0. So we're going to say summation of forces in the x-axis will be equal to mass multiplied by acceleration. Mass multiplied by acceleration, but since it's constant velocity, the acceleration there will be equal to 0, which means it's taking out this part of the equation. Hence, I'm going to remain with the summation of forces in my x-axis being equal to 0. And if this is what I have, I'm going to say what forces do I have? I have F, which is the positive force, and I have 20 and 12, which are opposing the direction of motion as negative forces. So I'm going to say F will be equal to 20 sine 40 plus 12. That means my force that is producing this motion is equal to 12. So this is approximately 24.86. 24.86 newtons. That is the force that is producing the action here. 24.86 newtons. You just plug in 20 sine 40. If you plug in 20 sine 40, you're going to get 12.86. Then you add that to 12, you're going to get 24.86 as the force F. So that, ladies and gentlemen, is the force F that is producing motion. But B of the question is saying we should calculate the coefficient of kinetic friction. Calculate the coefficient of kinetic friction. So we can bring the formula for friction here. And we know to say friction, or I can say the force of friction is equal to the coefficient of kinetic friction itself multiplied by the normal force Fn. So if this is the formula that we have for calculating friction, what are we looking for? We are looking for this value. of mu k, or the coefficient of kinetic friction, which means I can make it the subject to the formula by dividing both sides by the normal force Fn. That means my mu k, the coefficient of kinetic friction, will be the force of friction itself over the normal force Fn. So where are we getting the normal force from? We're going to go back to our diagram, or our free body diagram, and we're going to see the normal force is perpendicular to the surface, which means the normal force is here. That means I also forgot to include it when I was drawing the the free body diagram. We're going to have our normal force there. And if we look at our forces that are applying in the vertical axis, you'll notice that there's no motion in the vertical axis, which means the acceleration is also equal to 0. The forces are at equilibrium, which means Fn is equal to what? Is equal to 20 cos 40 degrees. So that, ladies and gentlemen, is the value of normal force that we're going to get. So we're going to get this value exactly and plug it in this particular formula. So I'll say my mu k will be equal to the force of friction, which is 12 newtons, divided by the value of the normal force, which is 20 cos 40 degrees. Therefore, my mu k will be equal to, let me just punch this into my calculator. My mu k will be equal to 12 divided by 15.32. And this is giving me exactly a value of 0.783. Meaning that, ladies and gentlemen, is our coefficient of kinetic friction, 0.783. We can go to the last question, which is saying, part C, which is saying we should calculate the mass of the block. Part 3, which is saying we should calculate the mass of the block. So they've given us the weight of the block already. It's 20 newtons. And to say weight is equal to mass multiplied by gravity. So if we have this value, we know the value of gravity. We can calculate the mass. So I'm going to say my mass will be equal to the weight divided by the acceleration due to gravity. And this will be equal to 20 newtons divided by 9.81 meters per second squared. That means my mass of the block will be equal to, let me just punch this, 2.04 kilograms. That means the mass of the block is 2.04 kilograms. And that, ladies and gentlemen, is all on question 1 of this particular tutorial sheet. So you can counter check. We've calculated the force applied as 24.86 newtons. We've calculated the coefficient of kinetic friction as 0.83, and we've calculated the mass of the block as 2.04 kilograms. That, ladies and gentlemen, marks the end of question 1. We can go to the next question, which is question 2. And question 2 reads, a 4-kilogram block is put down a rough incline of 30 degrees as shown below. A force of 2 newtons is applied down the incline with a friction force of 10 newtons as shown. Find A, the net force, B, the acceleration, and C, the gravitational force. Find the net force, find the acceleration, and find the gravitational force. So they've already given us a free body diagram, but what are we going to do? We're going to finish this free body diagram by indicating the forces that haven't been indicated here. So go to our blackboard. Now heading to question 2. I'll say my question 2 there. And I will draw my incline. I will draw a much bigger one so that we have enough space for everything. We have a block here. I'll make it as long as possible so that all the forces are shown. Then we have the horizontal surface, 30 degrees incline. The applied force is 2 newtons. Then there's a frictional force, which is 10 newtons. What else have we been given? They're given us to say the force is of mass 4 kilograms. Okay, so if the force is of mass 4 kilograms, that means there is weight acting on this particular object, and weight is pointing perpendicular, straight or vertically downwards. So we have our mg there, but since this is an incline, we're going to resolve these forces. This is also equal to 30 degrees. That means this guy, or the vertical component of the weight, is mg cos 30. The horizontal component is mg sine 30, like that. Okay, so if this is our free body diagram, that means, okay, so we also have a normal force, Fn there. We also have the normal force produced by the surface as Fn. So if this is our free body diagram, I'm sure now we can calculate all that is needed. So first they've said we should calculate the net force. Calculate the net force. So we're going to calculate the net force in the axis where there is movement. The net force is only existing in the axis where there is motion, which is the horizontal axis in this case. So we're going to say the net force will be this force subtracted from these two forces that are causing motion, these two forces that are on the left here. Because since they are the ones that are in the direction of motion, that means those guys are positive forces. So in order for me to calculate the net force, we're going to say those forces that are in the direction of motion subtracting the force that is opposing motion. So I'll say my net force, F net, will be equal to mg sine theta, or sine 30 degrees, plus 2 newtons minus 10 newtons, like this. So this will be equal to mass is 4 multiplied by gravity, which is 9.81 sine 30 degrees plus 2 newtons minus 10. Okay, that means my F net, the net force, will be equal to 4 times 9.81 sine 30 plus 2 minus 10. The net force, ladies and gentlemen, is if I plug this into my calculator, I'm getting 19.6. So we have 19.6 plus 2 minus 10, and this is giving me exactly 11.6 newtons. So the net force in the horizontal axis, or the force that is causing acceleration of this particular object, is 11.6 newtons. Part 2 of the question is saying we should calculate the acceleration. So acceleration, we're going to use Newton's second law to say the summation of forces in the x-axis. Summation of forces in the x-axis will be equal to mass multiplied by acceleration. So the summation of forces is already the net force that we've calculated in the x-axis, which is the 11.6 that are from that we're just from getting there. Now that we've found the 11.86, sorry, the 11.6, what are we going to do? We're going to say divide both sides by mass, even this side by mass. This is going to give us acceleration. So in short, our acceleration will be equal to the F net, which is the summation of forces in the x-axis, divided by the mass of this particular object. So the acceleration will be equal to the F net, which is 11.6, divided by the mass of this particular object, which is 4.0 kilograms. So that means our acceleration is basically equal to 2.9 meters per second squared. 2.9 meters per second squared. That is the acceleration of this object, ladies and gentlemen. We can go to the last part of the question, which is saying we should calculate the gravitational force. We should calculate the gravitational force. So how do we calculate the gravitational force in this particular scenario? It's a very simple question. Also, we're just going to say the gravitational force. This is part C of question 2. Gravitational force due to gravity will be equal to the mass of this particular object multiplied by the acceleration due to gravity. Because when they say the gravitational force, it's the same as they're just asking the force on the object due to the acceleration due to gravity. So it's more like we're just talking about the weight of the object, or not more like, but they are just basically asking about the weight of that particular object. So that will be 4 multiplied by 9.81 meters per second squared. So the force due to gravity, or the gravitational force, will be equal to 39.2 newtons. 39.2 newtons. And that's that, ladies and gentlemen. We are done with question 2. So thank you very much for watching this particular video. Make sure you subscribe to the channel. You like this particular video. You share And also you register to our YouTube channel. Remember, when you register, you are going to find all the solutions to the tutorial sheets that you need, your past papers, and all the preparatory materials that you need for your exams on our website or our app. If you're using Android, you can download our app on Google Play Store. And at register, just follow the procedure that I've indicated in the description of this particular video or the description of my YouTube channel. In case you're interested in watching more interesting concepts, just scroll down my YouTube channel. You'll find some of them and register with us. So until next time, stay blessed.